Alright, pre-calc, our part 2 about derivatives is going to start to look at some of the applications we can do when talking about taking the derivative of a function. And the first one we're going to look at today, the first application, is how to find the equation of a tangent line, which was briefly mentioned in the previous video, part 1. Okay, so to talk about a tangent line, we're going to actually talk about a secant as well. A secant is going to be any line that hits a curve or intersects a curve twice. And a tangent line then is going to intersect that curve once. Okay, so the problem here is if we want to find the slope of a secant line, well, since it hits it twice, you would have 2 points on the curve, and we could find the slope using those 2 points or those 2 intersections. Okay, the problem is when we talk about a tangent line, since it only hits it once, those 2 points are getting closer and closer together until they are 1 point. And the problem there is we can't find the slope with 1 point. But what we can do is if we take our derivative definition and use that, now you'll see since h is going to 0, this is where we talked briefly that these two are going to be the same point. So by taking the limit and saying that h is approaching 0, we're essentially taking 2 points and making them so infinitesimally close that they are the same point, and therefore we can use the formula for slope because we have 2 points even though they're infinitesimally close and find the slope. So to find our slope, we're going to use our derivative formula. So you might want to even add to the front of this, the slope of your tangent line equals our definition of our derivative, the limit as h approaches 0 of that big ugly thing. And after we find that slope, since we're going to be at some point, that point of intersection, we're going to know an x1 and a y1, and we'll have the slope of the tangent line from our derivative. We can do that and plug that in. So we'll have our x1, y1 from our point of intersection, our point of tangency, and our slope that we're going to get from our derivative. Okay, an example of that then, let's say I give you the function y equals x squared over 4, and remember y is the same idea as saying f of x. So I need to find first, and we're going to need this point, but not until later. First thing I need to do is find my derivative of f of x. So that's going to be the limit as h approaches 0 of, remember we have to plug in x plus h everywhere we have an x. So x plus h, the quantity squared over 4, minus x squared over 4, and the whole thing is still over h. Remember the whole point of the derivative, our limit definition, is to get rid of that h in the denominator. So I'm going to simplify that numerator as much as I can in a couple steps here. X plus h squared, x squared plus 2xh plus h squared, the whole thing over 4, minus x squared over 4, and the whole thing still over h. Okay, and simplifying our next step then, since we have common denominators in our numerator, I can rewrite that as 1 numerator, whole thing over 4, and the whole thing over h. Okay, going back a couple chapters, since we have 2 singular denominators here, we can actually write those as 1 denominator, and also our x squareds are going to cancel out. So I'm going to do 2 things in one step here. There should be an h with that as well. So we're going to have 2xh plus h squared, and the whole thing over now, this becomes 4h. Okay, here's our step where we want to cancel out that h, so I'm going to factor out. If I were to factor out an h and cancel out here, this would disappear, and one of those would disappear. So we're going to end up with the limit as h approaches 0 of 2x plus h over 4. And since we don't have an h in our denominator now, we can plug in 0, and we just get 2x over 4, or simplifying, we could write that as 1/2 x, or x over 2. Okay, so that is our first derivative. Now we need that to find the slope of our line. So if we want to find the slope of our line, we don't want y equals, we want to use this formula, y minus y1, this form, and x minus x1. Now that slope is going to change depending on what point we're at, and you were given the point 1 and 1/4. X equals 1, y equals 1/4. So the slope of this line at that point is going to be f prime of x, which is 1. So I can take that 1 and plug it in to my f prime of x, which is x over 2, and that's going to give me 1/2, or the slope of my tangent line. So now I have the slope, I have an x1, and I have a y1. The only thing I need to do finally is plug in, and I did equals again. So y minus 1/4 equals 1/2 for m, and then x minus 1, and that would be the slope of the tangent line. Okay, so that is how we find the slope of a tangent line. You have to find the first derivative first, and then once you find that first derivative, you just take your x value, you plug it in, simplify it, that will give you the slope of the tangent line, and then plug in the given x and y values. Okay, and that is it for part 2.